Hi guys, today we want to get the Kleene size tree for given DTD tree. So this is the DTD and this is the tree which is governed by this DTD, and we want to make the Kleene size tree for this tree. Okay, let's begin. If you see this rule, so first we go with the leaf node, and if you see this in the leaf node, we can see there is E1, and here we have rule for the E1, and rule for the E1 says it can have two elements, first child and next sibling, and first child can be either E1 or E3 and next sibling can be either E3 or E4. So let's choose. If we choose the left side, if we choose the left hand side, then let's put it 0, and if we choose the right hand side, let's put it 1. Same for here. If we choose the left side, then it's 0. If we choose the right side, then it's 1. So now here E1, the first node is E2 and E2 is the left node, so we just write 0, and this is the next sibling. In next sibling, it's the first node, so we write 0, and this is the first child, and first child is E2, so we write 0, and next sibling is E4. This is E4, so we write 1. And again for E1, first child is E2, this is E2, and it's 0. And for E4, this is E4, and we write 1, the next sibling. So what we do is now we delete these nodes. We don't need this node anymore, and we go to the next level. This is E3, this E1 level. And here if you see E1, this to E1 is the child of E5, and this E5 doesn't have any child. This E5 has only the first child, that is E1. Now if we see the rule of E5, then it says E5 can have either many E1s or one E2. So this means let's say if we can either choose this or this. If we choose this, then we write 0. If we choose this, then we write 1. So if we choose 0, then we can have many E1, and if we choose 1, then we can have only one E2. Here we see E5 has the first child as E1. This means we can have many E1. So here we have only E1. So obviously we choose the first part. So we write 0 because we choose E1s, and we write how many E1s are there. There are 2 E1s. Let's close these things. So we say there are 2 E1s, and we join these things to these 2. This E5 doesn't have anything, so we just write 0. We choose 0, and we don't have anything. And let's go to this E5. It has one E1, so we choose this part, so we write 0, and we have only one E1, and we join these 2 here. Okay, we are done now. Now let's come to this E6. And if you see, the rule of E6 says E5 plus. This E5 plus means it's equivalent to E5 comma E5 asterisk. So E5 plus means you can have first child as E5 and next sibling as many E5. So when you see here E6, then it says it has 3 E5, so obviously this is the first child, and you can have many next sibling. So there is 1 E5 and 2 next siblings. So what we do is, according to this rule, obviously E6 will have one child as E5, so we don't need to save this. We only need to save there are 2 further E5, so we just write it 2 here and delete this node, and we join this to this E2. And obviously we only save the root element, so we don't need to save this, and we join this. So finally the tree is, so we have 2 here, then 0 here, then 2 here, then 3 zeros and 1, then we have 0 here and 0 here, then we have 0 here, 1 here, then 0 here and 1. This is our Kleene size tree, and we can also write it as a bit vector as, so this 2, this 0, then this 2, then 3 zeros, then 1, then 2, then again 2 zeros, then we come here, again 0, then 1, then 0 and 1. And this is our Kleene size tree.